Hello students, welcome to today's session of chemistry. As you all know, we have started studying 7th lesson of your syllabus, that is modern periodic table. This is our second session. We will just revise what we learned in first session. In first session, we started studying about the periodic table, basically given by Russian chemist Dmitry Mendeleev. Mendeleev arranged 63 elements which were known at his time in a typical manner, and for that he introduced his periodic table. Afterwards, after the discovery of atomic number by Henry Moseley, which is more fundamental property than that of atomic mass, the law which is given by Mendeleev was somewhat revised, and it is called the modern periodic law. And that law stated that the physical and chemical properties of the elements are periodic function of their atomic number and not the atomic mass which was given by Mendeleev. And hence, this revised version of the Mendeleev's periodic table came into existence and is called modern periodic table, or we call it long form of periodic table. It is most convenient and widely used form of the periodic table. Now, in the previous session, we learned about the classification of elements, how it is done by using modern periodic table. This table has horizontal rows intersecting the vertical columns. Thus, it gives rise to a number of boxes. The horizontal rows are called periods and the vertical columns are called as groups. There are in all 7 periods, as you can observe here also. There are 7 periods and 18 groups, numbered as 1 to 18. Now, in total, 118 elements are accommodated in this modern periodic table. This table can be classified in 3 different ways, as groups and rows, or groups and periods. Like, it can also be classified as S block, P block, D block and F block elements. Also, we can identify the metals, non-metals and metalloids in this periodic table. So, we can classify the same number of elements by variety of ways. Now, as we learned that atomic number, or Z, or it is the number of protons, or we can say it is the number of electrons as that is more fundamental property. And this whole periodic table is based on the atomic number, and the arrangement is done that from left to right these elements are placed in the increasing order of their atomic number, and in single group there are elements with similar physical and chemical properties. Now, in today's session we are going to learn about the periodic table and electronic configuration. As the number of elements, or these elements, when they are arranged in increasing order of their atomic number, periodicity is observed in their electronic configuration, and hence that reflects in the characteristic structure of the modern periodic table. What is periodicity? As I told you, every property repeats after a certain number of elements, and hence when we observe a column or a group of elements, we will observe that the elements in the same group, they show similar chemical property. That is called periodicity. The same is observed in case of electronic configuration also. What is electronic configuration? Electronic configuration is arrangement of electrons in various shells, subshells and orbitals. Now, we have accepted structure of atom that is given by Rutherford. The structure of atom shows that at the center of the atom there is positively charged nucleus containing protons and neutrons, out of which protons equal to Z, that is atomic number, are there in the nucleus along with neutrons which are neutral in nature. The electrons, which are same in number as that of protons, are revolving around the centrally located nucleus in various shells. These shells have energy in increasing order from the nucleus to the last shell. That means the shell which is near to the nucleus has lower energy, and as we move away from the nucleus, the energy of the shells goes on increasing. These cells are divided into different subshells, and the subshells have different orientations called as orbitals, and electrons are accommodated in orbitals. Understood? You will understand it in a better way when we learn structure of atom. You know, your teacher Balsarab madam, she has started that lesson, that is structure of atom. Learn it carefully so that you will understand in a better way what is electronic configuration. Electronic configuration in periods we are going to learn in this session. For that, in short, I will try to explain what is electronic configuration. Up till now, that means up to 10th standard, you write when, suppose atomic number is 11, you write 281, the electronic configuration as 281. That means in the first shell, 2 electrons will be accommodated. In the second shell, it has a capacity to accommodate 8 electrons, and the remaining electron will go in the third shell. And when third shell will be complete, the remaining electrons will go to fourth shell, like that. So K, L, M, N are the shells placed from nucleus to the outermost shell. That means too near to the nucleus is K shell with the lowest energy, and then L shell, then M, and then N. K, that is quantum number 1, 2, n equal to 1, n equal to 2, n equal to 3, n equal to 4. It is said like that. N is the quantum number, the principal quantum number. That means K has quantum number or n equal to 1. It has lowest energy. Now, K shell, first shell, is divided into only one subshell. It has only one subshell, that is S subshell. And S has spherical orientation, so it has only one orientation, that means one orbital, hence it can accommodate 2 electrons. First shell, K shell, having one subshell, S subshell, and in S subshell there is only one orientation, that means one orbital, and hence each orbital can accommodate 2 electrons. That means in the first shell, it has a capacity to accommodate 2 electrons, K shell. Hence, I have given you one example, sodium. With atomic number 11, you call it first shell. 2, 8, 1, you write. 2, that is first shell. 8, that is second shell. Now, second shell, L shell, principal quantum number 2. It has 2 subshells. It has 2 subshells, S and P. S, that is one orientation again, that means it has only one orbital. P has dumbbell shape and it has 3 different orientations along x-axis, y-axis and z-axis. That means P has 3 orbitals. And hence, in each orbital, as there are 2 electrons, maximum 2 electrons can be accommodated. That means P has a capacity to accommodate 6 electrons. That means second shell, L shell, has 2 subshells, S and P. S can accommodate 2 electrons, P can accommodate 6 electrons. That means total 8 electrons. So second shell has a capacity to accommodate 8 electrons. Now third shell, M shell. It has 3 subshells, S, P and D. We learned about S. It has 1 orbital, 2 electrons. Second shell p orbital. It has 3 orientations, 3 orbitals. That means 6 electrons. In the same way, D orbital has 5 different orientations. That means 5 orbitals. That means it has a capacity to accommodate 10 electrons. Likewise, F has 7 different orientations, but F will arise in the fourth shell. Fourth shell, KLMN now, N shell, with quantum number, principal quantum number 4. Fourth shell, 4 subshells, S, P, D and F. F has 7 orientations, that means 7 orbitals, and it has a capacity to accommodate 14 electrons. That means fourth shell, N, capital N, nth shell, has 4 different subshells, S, P, D and F. S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, and F can accommodate 14 electrons. That means 2 plus 8 plus 10, that means 20, plus 14. 2 plus 6, that is 8, plus D has 10, that means 18, plus 14, that means 32. That means fourth shell can accommodate 32 electrons. You are going to learn all this in structure of atoms. How many electrons are accommodated? There are 3 different rules which govern this arrangement. But up to 10th you learn about only this, 2, 8, 8, 10, 2, 8, then 18 and then 32, like that. But now for this year you have to go in deep. That means you have to write their shells as well as subshell. Not only 2, but you have to write 1s2. That means first shell with S subshell can accommodate 2 electrons. It is written 1s2. Second shell 2s2, 2p6. Third shell 3s2, 3p6, 3d10. Likewise fourth shell 4s2, 4p6, 4d10, 4f14. Understood? Fifth shell also has 4 different subshells, SPDF. 6 has 3, 7 has 2. That you will learn in the structure of atom. I am just telling this because I am going to tell about electronic configuration in periods, how that changes and how periodicity we can observe in this arrangement. Now let us begin with. We noted earlier that periods in the modern periodic table are numbered as 1 to 7. Every period ends with complete octet configuration. What is octet? That is, one rule is the Octet Rule that tells us that when there are 8 electrons in the outermost shell, then that element is stable. And if the number of electrons in the outermost shell is not 8, then that element tries to complete the octet. If less number of electrons are there, it can gain the electrons. If more number of electrons are there, it can donate the electrons or it can share the electron. Anyhow, it can complete its octet and then becomes stable. In that completion of octet, it can form compounds with different elements. And hence, this is called Octet Rule. Hence, many of the elements in nature are observed in the compound form because they are stable in compound form. Na with 11 electrons will not be stable till it forms compound with chlorine which has 17 electrons. That means chlorine has 7 electrons in the outermost shell. It will try to accept 1 electron from any element which can donate it. While sodium has excess 1 electron, it can donate it to chlorine. And hence NaCl come together to form a compound where sodium can donate the electron to the chlorine and chlorine accept that electron and complete its octet, and sodium also can complete its octet. So that is called octet rule. And if you observe in the periodic table, each period completes its octet configuration. Only first period is exception. it has only two elements. You have drawn that periodic table in your notebook. You can observe that. In the first period, there are only two elements, hydrogen to one end and helium to another end. Because helium has maximum of 2 electrons in the outermost shell. So duplet is complete. That is exception. So first period with 2 electrons, we also get a stable electronic configuration in helium. So the next period, every period we can say, begins with addition of electron to the next shell of higher energy compared to the previous period. Suppose first period has only two elements, hydrogen and helium. Then lithium, if we see the second period begins with lithium, atomic number 3. That means first shell with 2 electrons is complete now. Next shell with higher energy start to begin with lithium, atomic number 3. That means second shell 1s1. 1s2 is complete with helium. 2s1. 1s2, 2s1 will be the electronic configuration of lithium with atomic number 3. The first shell gets filling along the first period from left to right if we go. As the first shell can accommodate only 2 electrons, there are 2 elements in the first period, namely like this: hydrogen 1s1, helium 1s2. As atomic number 2, that means 2 electrons are there, those can be accommodated in the first shell, and first shell is complete here. First shell, only one orientation, that means S subshell, it has a capacity to accommodate 2 electrons only. Third electron has to go into the next shell, and hence atomic number 3, that means when there are 3 electrons which are in the lithium, then second shell begins to fill. Lithium, after that lithium is beryllium with atomic number 4, that means 2s2 will be complete. And from beryllium, if we come to boron, atomic number 5, that means 1s2, 2s2, 2p1. And when second shell is complete, that means when we come to neon, atomic number 10, then second shell is complete because second shell has a capacity to accommodate 10. That means 8 electrons. First shell 2 and second shell 8. That means total 10 electrons. But neon, up to neon, atomic number 10, first and second shell are complete. Now, the 11th electron will go to third shell because second shell is complete now and our period also ends there. Third shell begins to fill from the third period. Fourth shell will begin to fill from the fourth period. That means the arrangement of the elements is in the horizontal rows, it is according to the filling of the new shell. That means every period begins with a new shell, filling up of electrons in the new shell. You will observe that if we will go step by step towards that. So this is all about first period. It has 2 elements, hydrogen and helium. Helium has complete duplet and not octet because helium atomic number 2 and first shell ends with 2 electrons only. Along the period, atomic number increases by 1 and 1 electron is added to the outermost shell till it is complete. So, this is your first period. In between there are no elements, hydrogen with atomic number 1 and it is helium here with atomic number 2, that means 1s1, hydrogen, helium, that means 1s2. You write helium with 2 only, that means first shell, S subshell, 2 electrons. Those are written as superscript above level. So, this is all about first period. We will understand when we learn about second and third period gradually. Now, let us start with the second shell. Electrons are filled in the second shell along the second period. The second period thus begins with lithium. Lithium atomic number 3, hence electronic configuration 2-1. That means 1s2, 2s1. Second shell, 2 number 2 indicates number of shell. and S will indicate subshell. So second shell with subshell S, there is one electron in the second shell, and second shell just has started to fill up from the lithium, and lithium is the first member in the second period. Now we will go from left to right along the period, and the final element is a neon with atomic number 10. That means 1s2, 2s2 and 2p6. Second shell, two subshells S and P, S with 2 electrons, P with 6 electrons. That means the capacity to accommodate electrons in the second shell is 8, and that shell is complete with neon. Up to neon, the atomic number 10, the second shell is finished. And the third period will begin with the filling up of third shell. Third shell, 3 subshells S, P, D, and when those are complete, the third shell will also be complete. So second shell, first member is lithium, last member is neon. Neon with 8 electrons in its outermost second shell has complete up. Second shell, which is the outermost shell, is second shell, and it is complete with 8 electrons. That means the shell has completed its octet. And according to octet rule, neon has stable electronic configuration. Hence, it will not react with anybody else to form a compound. That's the reason why these elements or inert gases or noble elements which are in the last group, they have completed octet or completed electronic configuration. Hence, they don't form any compound with any other element. The second shell has electron capacity of 8. It gets filled along with the second period as the atomic number increases. Thus, there are 8 elements in the second period. And this is your first and second period. Can you see here? So, the second period begins with lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, and the last element is 10, that is neon, with complete octet. Neon 1s2, 2s2, 2p6. So this is all about second period. Now third period. We will start with third period. There are 8 elements beginning with sodium atomic number 11 to argon atomic number 18 in the third period. They have condensed electronic configuration. We can describe it as neon. Neon in the square bracket indicates that up to neon, the electronic configuration is there in the square bracket. So neon, that means 1s2, 2s2, 2p6. Totally, we don't have to write every time the complete electronic configuration. We can write as a condensed or in short electronic configuration like this. Neon has electronic configuration up to second shell. Second shell is complete with neon. Now third shell begins. Third shell has a capacity to accommodate 2 plus 8 plus 10, 2 plus 6 plus 10, 18 elements. But in the third period also there are only 8 elements. What about 3D subshell then? 3D is placed after 4s. There is one more principle tells us that electronic shells or shells and subshells are filled according to the energy they have. 4s has less energy than that of 3D, and hence after 3s, 3p is filled, then 4s is filled, and then 3d is filled. Hence, in the third period, if you observe in a periodic table, 3s and 3p are there. That means again there are 8 elements, and hence 3p6 up to 3p6 elements are there in the third shell. That means neon up to atomic number 10, from 11 to 18. That means 3s 1 to 2, 3p 1 to 6. Every time only one electron is added if we move from left to right. Hence 3s when gets filled, then 3p1, 3p2, 3p3, 3p4 like that. When it is 3p6, that is argon. We will see that also. In the third period, as a result of completion of the third shell there are 8 electrons, and this is third period. It has only 8 elements, 3s1 to 3p6. Now neon with 10 atomic number is complete. 3s1 is sodium. Square bracket neon and then 3s1. That is sodium. That means 10 plus 1 is 11. When we come to magnesium, it will be 3s2. As there is dash, that means 3s2 to 3s1 to 3s2. 3s1 is for sodium, 3s2 for magnesium. And now when we come to aluminum, your electronic configuration, how you are going to write that? Atomic number 13, neon with 10, 3s2, 3p1. Square bracket neon, 3s2, 3p1 will be aluminum, 3p2 will be silicon, 3p3 will be phosphorus, 3p4 will be sulfur, 3p5 will be chlorine, and 3p6 will be argon. And again at argon, the outermost shell will be, or that third shell will be complete. 3d is there, but it will be filled after 4s because it has more energy than 4s. Hence, there are only 8 elements in the third period as well. Now we will learn about fourth period. The fourth period begins with naturally filling of 4s subshell. The first two elements of the fourth period, that is first one is K, that is potassium, atomic number 19. Hence, its electronic configuration will be square bracket argon now. Neon for the second period. Third period, which element has complete octet? That is argon. Atomic number 18. What is electronic configuration of argon is 1s2, 2s2, 2p6, 3s2, 3p6. That is total 18. And after argon, only one electron is there. That means 19. That one electron will go to fourth subshell now. Fourth shell with S subshell, that is 4s1. After potassium is calcium with atomic number 20. That means argon 4s2. If we go further, gallium, then next member of the family will be Scandinium. And for that, now we will learn about it. This is fourth shell, first element and second element. 4s1, 4s2. Now, the principle I told you that the electrons will enter according to the energy. These shells and subshells are the energy levels. The one which has lower energy will be filled first, and the one with the higher energy will be filled later on. That is above principle. And according to that, after 4s, 3d will be there. I told you earlier also, after 3s, 3p, and after 3p, 4s has less energy than 3d. Hence 4s with 2 electrons will be filled first, and then 3d with 10 electrons. And then 4p will arise. That is told, the rule is, and this arrangement or this fulfilling of electrons will be governed by above principle. And that again you are going to learn in structure of atom. Now, filling of 3d subshell results in the next 10 elements of the fourth period. That means from Scandinium, that is with atomic number 21, to that of zinc, atomic number 30. So from Sc, Z equal to 21 to Zn, Z equal to 30, the electrons will be filled in 3d subshell. That is atomic number 21, 3d1, 22 will be titanium, 3d2, third vanadium, V, atomic number 23. The third electron will also go to 3d3, 3d4, 3d5 up to 3d10. When we come to 3d10, it is zinc with atomic number 30. Now, the electron, 31st electron, will now go to 4p subshell. The 31st electron, after this, the electron enters the subshell 4p for the next 6 elements, because p has a capacity to accommodate 6 electrons. That means 4p1 to 4p6. Atomic number 31, gallium. It will be square bracket argon, that means 18 electrons, 4s2, 3d10, that means again 18, 20, 30 will be finished here at 3d10. 31st electron will enter 4p. 4p has a capacity to accommodate 6 electrons. 4p1, 4p2, 4p3 and 31, 32, 33 like that. When we come to 36, that will be 4p6 and that is krypton, again a noble gas with complete octet. So fourth period ends at krypton with atomic number 36. The fourth period thus contains in all 18 elements, 2, 10, 6. Understood? 2 in 4s, 10 in 3d and 6 in 4p, total 18 electrons, and there are 18 elements in the fourth period. That is called long period. Here these two, potassium and calcium, the electrons will go to s orbital because they are placed in s block. From Sc21 to zinc 30, these 10 electrons will go one by one into 3d subshell, and 3d has a capacity to accommodate 10 electrons, and there are 10 columns and the 10 electrons will be accommodated in 3d subshell, and which is placed, these elements hence are placed in d block. From here to here is p block. P block belongs to the last electron. When enters p subshell, that element goes to p block, and p has a capacity to accommodate 8 electrons. Hence, from gallium to krypton, all the electrons will go into 4p1, 4p2, 4p up to 4p6, where krypton is there from 4p1 to 4p6 krypton. That means 4s1, 4s2, 3d1 to 3d10, 4p1 to 4p6. That will be your fourth period. Accordingly, fifth period, it can also accommodate 18 elements because it has orbitals like 5s, then 4d and then 5p. Likewise, 4d also has more energy than that of 5s. Hence, 5s will be filled first, then 4d and then 5p. So, fifth period is like this. First member is rubidium, atomic number 37, then strontium, atomic number 38. The electronic configuration will be square bracket krypton, then 5s, 5s1, 5s2. After 5, 4d will start filling because 3d is complete here. 4d has more energy than that of 5s. Then after 5s, 4d1, yttrium to 4d10 up to cadmium. These 10 electrons will be there in the 4d subshell one by one. And then 5p will start filling up. And from indium to xenon, the 6 electrons will be there in the 5p subshell. And at xenon, the fifth period will end, and it's again xenon has a stable electronic configuration with complete octet. Now what about sixth period? Sixth period accommodates 18 as well as 14 of that of first series of a block. Accommodates 18 normally, but in the third period, as we have seen here, these 57 to 71 elements are there in the sixth period only. So in all, if we calculate, there are 32 elements in it. Now, here, first, according to this arrangement, we can easily identify what will be the electronic configuration. First 6s subshell will start filling. After xenon 54, 55th element will go to 6s1, then 6s2, barium. Then 57 to 71 are lanthanoids, which are placed separately at the bottom. Then 72nd to 80. Lanthanum also belong to D block. From lanthanum to mercury, atomic number 80. These elements are in the 5D subshell. This is 6s, then 5D, then then 4f and then 5D. 4f, that means after lanthanum, the 14 elements, that means 5f, 4f subshell will be filled, then 5D will start filling, and finally 6p with 1 to 6. That means in all, 2 plus 14 plus 10 plus 6. That means 32 elements are there in the 6th period. And 6th period completes with 6th shell. And 6th shell has 6th shell is complete with 6s. The 6th period has elements in which electrons are fulfilled in 6s, then 4f, and 5d, and then 6p. Same way, 7th period. 7th period can also accommodate 18 of its own, then 14 of F block, and total 32. And the successive filling will be 7s, francium and radium. Then 89 to 102. Actually 89 is actinium, and that belongs to D subshell itself. After actinium, 90 is thorium from 90 to 103, which are placed separately in the second series below the periodic table. These elements from thorium 90 to 103 that belong to 5F subshell. Then we'll fulfill, this is 6D. From actinium to this is canadium, and where they are fulfilled as 6D subshell. Then will come 7p. 7p from atomic number 113 to 118, that is total 6 elements. Again, 7th period has a capacity to accommodate 32 elements. Now you may get confused somewhat, but still I have given you basic knowledge, and you will understand it in better way when you learn to write the electronic configuration, and that you will learn when you will be that lesson started by ma'am, Basaraf ma'am, that will be complete. That is structure of atom, in which you will learn how to write the electronic configuration, what are the reasons behind it, what are the rules those govern that electronic configuration, everything. But as I have started with periodicity, I have given you basic knowledge. That means the total arrangement made by Mendeleev is very, very perfect. Here, if you see the periodic table, there are in all 4 blocks: S block, P block, D block, and F block. Now, S subshell has a capacity to accommodate 2 electrons, and there are 2 groups in the S block. There are 6 groups in the P block because P has a capacity to accommodate 6 electrons. There are 10 columns or 10 groups in the D block because D has a capacity to accommodate 10 electrons, and there are 14 columns in F block because F has a capacity to accommodate 14 electrons. So SPDF arrangement is here. Only thing is some anomalies, something variation is there because 3D comes after 4S, 4D comes after 5S, and 4F comes after 6S. That is also again some anomalies there. That is again I told you there is above principle that tells us which subshell will be filled first and which later on. That you will learn in the lesson started by ma'am. So this is all about today's session. If any confusion arises, please ask me on my personal number. So assignment. So this is all I have told you just now. So assignment second will be write first and last element of each period and its general electronic configuration. If you are able to write it, write down now. Otherwise, just write down the first and last element. And when you learn about the structure of atom, and if you are able, when you are able to write the electronic configuration independently, then only send it to me. Thank you.